we have two different live stream. Not this one. You're going to go to the other live stream. My Dr. J's live stream. Okay, no one's in yet. Yes, I'm live. So live, go ahead and join in. Yep, and you should see me there, right? Okay, so what do you want me to do? Like, you're gonna need to tell me when you want me to be doing this.
No, you do just your own way. No
But when?
Right now.
Okay, but when are you gonna bring this footage
This
into
yeah,
there?
Yeah, definitely okay, I see. At 12:05, can you come?
12:05.
Yeah. For
Yes.
5 minutes, okay?
Yes.
12:05. Or any time between 12 to 12 time, yeah? Any time.
Okay.
Just
12. All right. We are live on Dr. J's channel. So, how you doing? Right now, we only have one viewer, but anyway, say hi. Say hi.
Hi.
Okay. And if you want, you can go to YouTube and just check and make sure that it's working. All right, so we are preparing now to launch our two balloons. We're going to start filling the helium in about 5 minutes. It takes about 45 minutes to actually fill one balloon, and we are in the final stages of setting that up. And if you take a look over here, you can see what's happening. So we have a 1,600 gram latex balloon that we're attaching to the top of the balloon. Say hi, everybody. We're just streaming some videos. How's the regulator? Is it good? Yes, awesome.
I haven't turned the tank on yet.
That's fine. That's good. So we have helium tanks, and we're going to feed the helium into an interface that is on this adapter down there.
Wait, Dylan. Yeah, no. So they
The
had
snips.
it so that
We're not folding this, right?
this is the but it's heavier. We think it's fine.
That's fine.
Okay, so we'll just do 2 zip ties and call it a day.
Jack,
This is the less
you
force.
tied this knot well. It's good.
Okay, yeah.
Zip tie bags back in suitcase.
We need duct tape for that, right?
Just watch out for these payloads here.
Yeah. Do I kick it?
A little bit, but yeah, it's okay.
Mark's color should be like this.
So we send a message.
I don't know where the duct tape went. So the weather's clearing up a little bit, still hazy, but viewable. Not quite a clear sky here in Frisco, Texas. The idea is that this balloon will launch from here and head basically northeast, almost due northeast, and land in Paris, Texas. That's right. So that's the current flight trajectory. That's our forecast. We're going to launch 2 balloons. The first one is a NASA-sponsored project through the Nationwide Eclipse Ballooning Project, NEBP. And we got the fill command right now. We have the fill command's been given. So Leah is turning on the cylinders here and giving gas to the regulator.
Starting helium.
Oh, no.
Okay, you guys started.
We're partnering with the University of North Texas, and we're partnering with Lincoln University. And let me give you a little tour of the payloads.
Yeah, that's what I'm doing.
It's Dr. Beline there, the director of the Student Space Programs Lab. Live stream video from this payload. High energy particle detector from Lincoln University.
Are we fully open?
Atmospheric package. Another atmospheric package, as well as attitude control, velocity acceleration. And then GPS tracking and satellite communication. To know if we have the right amount of helium in there, we have a pre-measured amount of water that at a specific weight. And so when the balloon can lift these bottles and be neutrally buoyant, then we know that we have the right force from the helium that's in the balloon. We're hoping for a calm wind because we need to hold on to this balloon for maybe 45 minutes because we have to then fill a second balloon and they need to be relaunched at approximately the same time. So we have ourselves a little problem of holding on, a timing challenge of holding on to a balloon for 45 minutes and then just waiting for it. This is Austin. Hey, Austin.
Hello.
How you doing? So tell me something. What's interesting?
What's interesting? Well, we have these set up here.
What are those?
On the left, it's a gritty antenna. That's going to be receiving signals from our RFD 900 payload.
Yes.
And what that does is it has a GPS on it, and it also sends us other location data and orientation data of the
Great.
balloon. And then we have our Ubiquity antenna over there. And that is able to track our Iridium payload, where we can actually locate the direction of the balloon. And it also receives signals for our live stream.
Great.
For camera payload.
Great. Thank you. I don't want to distract you anymore. So thank you. Dr. Shimashevsky from Lincoln University. And here's our setup. I'm just running a live stream. And nothing wouldn't be complete without some energetic music. We're expecting totality to happen here at around 1:43. It takes the balloon about 45 minutes to reach altitude. Our target altitude is 70,000 feet, or approximately 21 kilometers, more or less. And so our target altitude is 70,000. We're going up at about 8 meters per second is our target ascent rate. So 8 meters per second. It should take about 45 minutes. This particular balloon has a venting system where we can open a vent, let out some of the helium, and then it will hopefully be neutrally buoyant at our target altitude. Special shout out to Kirsten McTurnan in the chat. I don't know if you can hear me right now. Maybe you can give me a message in the chat if you can hear me. All right, so again, you're tuning in to Dr. J's live stream. We are here at UNT Frisco in the Dallas area, Texas, and we are preparing to launch 2 high-altitude balloons up to about 70,000 feet. And we have a host of scientific payloads on there, as well as a camera on each one. We will be doing GPS tracking. We've already forecasted that given our ascent rate, given our target altitude, that we're going to land in Paris, Texas. Paris, Texas, everyone. So that's where we're expecting this balloon to land. Let me take you back to a live stream view of the balloon. So the balloon is now reaching close to its target volume, and with the target volume, it corresponds to a weight. So what we want to do we want to fill the balloon with just enough helium that when it lifts these bottles, it's neutrally buoyant. So we're just going to keep filling until this pre-measured mass or weight is just barely lifted off. Then we're going to have to hold it. Sam, tell me about holding balloons. What's it like?
It's usually you just kind of hold on to like big mass. You kind of feel like Mary Poppins sometimes.
Why are you wearing gloves?
Because the oils on your skin can really affect the material of the balloon and make it pop way sooner than it's supposed to.
Okay. And do you know the target height of what this is going to?
Ideally, we get to about 70,000 feet during the totality.
Okay, great. Thanks. How much weight do we have here, more or less?
About 23 pounds.
Okay, so 23 pounds. And how much does the payload weigh?
It's about 10 and a half pounds.
Okay. So we add some extra weight so that way there's a lift force. We don't want it to be buoyant at ground zero. We want an extra lift. Giovanni, tell me, what are you doing right now?
Right now we're just holding the balloon, keeping it in place, trying to make sure that it doesn't veer off from where we want to launch it, or at least hold it for now.
How would you describe the wind right now?
The wind? It's going down a little bit. I checked earlier, it was around 8.5 miles per hour.
Okay.
But I checked around 20-30 minutes ago, and it was about half that.
All right.
4 miles per hour. So
Fantastic.
I'll probably check again once we have enough people holding this. Or I'll either check it again or give it to someone else probably.
Okay. Great. Davian, hi. Say hello to everybody.
Hello, everybody.
So, how long do we have to hold this balloon while we're filling the second one?
So it will be around 30 minutes holding this first balloon until we get the second one getting ready. After that, around 12:10, we're gonna be launching the balloon. Hopefully, we'll launch the second one 45 minutes after.